Hello and welcome. Bhaskar Napte from Pharma Growth Hub. We all know that the stability testing is a vital part of any product development. It is, however, quite resource consuming, and with 6 month or 12-month data is generally required for new product licensing. It is also often on the critical path of development. Therefore, it is vital that the stability protocols are designed both properly to ensure regulatory approvals and efficiently to minimize the time and resource required. Fortunately, there are well accepted procedures, namely bracketing and matrixing. So this bracketing and matrixing helps us to reduce the amount of stability testing required. Now, these are the procedures for reducing the number of samples of product tested for stability, which when correctly applied should result in neither loss of data quality produced nor a significant change in the predicted shelf life. And that is the part of our today's presentation. In this talk, we will primarily focus on to the bracketing stability study. So how the bracketing concept can be used for minimizing your stability testing load. So if you look at the stability guidelines, especially on Q1D and Q2A R2, you will find that there is a mention about the bracketing and matrixing. The Q1D guideline from the ICH talks about bracketing and matrixing designs for stability testing of new drug substances and products, whereas Q2AR2 talks about the stability testing of new drug substances and products. And both of them talks about bracketing and matrixing concept. Let us understand the definition of stability before we move on to the bracketing designing concept. So stability is defined as a continued conformance of drug or drug product to its specification throughout its retest or shelf life. So we are going to confirm with the help of stability study that the product really meets its specification from its beginning till the end of its shelf life in case of drug product, or maybe the retest in case of API or the drug substance. Very much there is a concept which is called as a full study design. Now in the full study design, the sample for every combination, all design factors are tested at all time points. Means you are not going to skip any of the stability time points. You are going to test all these time points. That is the full study design. Now there is another concept which is called as a reduced design. The samples for every combination, all design factors are not tested at all time points. So there are certain ways of omitting the stability testing time points, and that is called as a reduced design. So how one can implement the reduced design in the place with the help of bracketing and matrixing. So we will talk about how the bracketing concept can be utilized to implement reduced design. The very important point that one has to understand that any reduced design should have the ability to adequately predict the retest period or shelf life. So whenever you are going to propose any reduced design, make sure that that particular proposed reduced design is must have capabilities to predict the retest period for APIs or the shelf life for the drug product. Let us talk about the bracketing now. So in this presentation, we will only cover bracketing, and in the next presentation, I will talk about matrixing concept. Let us first begin our talk with the definition part. Now this is the definition given in the ICH guideline Q1D. So bracketing is the design of a stability schedule such that only samples on the extremes of certain design factors, example strength, container size or fill, are tested. and we will talk about those how to understand and identify the extremes of the design factor. The very important assumption while making the bracketing design is you must confirm that the intermediate level that you are not going to test as a part of your stability plan, because you are only going to test the extreme conditions, and the intermediate conditions will be omitted from the stability plan. So it is very important to understand whether the stability of the intermediate level is really represented by those extreme conditions, because without testing the extreme condition you are going to confirm, okay, now this is going to be a shelf life for the intermediate condition. I mean, without testing the intermediate condition, you are going to confirm, you are going to give the shelf life or retest period for those intermediate conditions. And based on what? Based on just extreme conditions. So it's very important that your extreme condition must predict the stability of your intermediate levels. And for example, over here now, let us say you have a tell me certain product with three different strength. Tell me certain 20 mg, tell me certain 40 mg, and tell me certain 80 mg. So which one is the extreme cases over here? The 20 mg is the lowest level claim product, and 80 mg is the highest level claim product. So the 40 mg becomes your intermediate level, and you can use bracketing standard and omit the 40 mg tablet from the stability testing plan. So the 20 mg and 80 mg will be tested, and 40 mg will be omitted from the stability testing plan. Let us understand what are the various design factors that one can consider while using the bracketing approach. And there are three important design factors you must consider. The one is strength, the second one is container size, and the third one is the container fill. Now below are very important assumptions or considerations one has to look into. Make sure that the excipients, the manufacturing process amongst the strength are similar. API to excipient ratio is also similar when it comes to strength to strength. The container closure system characteristics like wall thickness, closure geometry, surface area to volume ratio, headspace to volume ratio, water vapor and oxygen permeation rate per dosage unit. Now, these certain characteristics also needs to be considered before you finalize your bracketing design, because it is very important whenever you are going to decide onto the extremes of the designs. All these factors are very important. Same is the desiccant. In case if you are using a desiccant for one strength, and if you are not using for the another strength, then that cannot be just a apple to apple comparison, and you cannot consider that during a bracketing design. Make sure that if there is a desiccant present into one strength in one pack, it must be present into the another packs too. Shelf life. Now the shelf life over here is going to be decided upon the shelf life of our extreme conditions. So the intermediate condition shelf life will be dependent on to the shelf life of the extreme conditions. And sure, you cannot have the multiple shelf lives. For one strength, 1 year, and for the another strength, 2 year, it is not going to be possible. The shelf life will be based on to the least shelf life across found design. It may be a for one strength, it can be a low shelf life, but that low shelf life will be applicable across all the strength, all the design, and the storage condition is certainly going to remain same. So these are the very important points that one has to consider while designing a bracketing plan. Let us now talk about the first factor, that is the strength. So how the strength factor can be used? The bracketing can be used for a product with different strength. As we just talked about, tell me certain 20, 40 and 80 mg tablet. Now they are different strength, but when it can be applicable. So bracketing can be applicable for the different strength only and only with identical or closely related formulations. So if these multiple strength are having the identical or closely related formulations, then only the bracketing design can be applicable for the strength. Now what is meant by identical or closely related formulation? Let us have a look for a few examples over here. And the first one is for the capsules. So for capsules of different strength made with different fill plug sizes from the same powder blend. I mean, this is just a dose proportionate formulation, isn't it? So you are having a fixed API to excipient ratio across all the dosage strength. Tablets of different strength manufactured by compressing varying amounts of the same granulation. Essentially, we are talking about the dose proportionate formulation in case of tablet also. The oral solutions of different strength with formulation that differ only in minor excipients like colorants and the flavoring agents, except all another factors must remain one and the same, like API to excipient ratio. So in case if you meet this requirement, then the bracketing design can be applied across the multiple strength for a given product. Let us take an example of a oral solid dosage form, and this is the valsartan capsules 40 mg, 80 mg and 160 mg. Now look at their composition and you will find that this all three dosage strength are having same API to excipient ratio. Look at the total fill weight. It's 200 milligram for 40. It is exactly double for the 80 milligram. And then again it is exactly double for 160 milligram. So this valsartan capsules 40, 80 and 160 mg are dose proportionate formulations. And this is one of the requirement to use bracketing design. Now having said that, now we can use the bracketing design for studying stability for valsartan capsules 40, 80 and 160 milligram. Now here is the plan now. So what we learned as a part of bracketing definition, we need to understand, identify the extreme conditions, extreme designs, and then the intermediate design or intermediate steps can be omitted from the testing. Now out of these three strengths, the 40 and 160, right, the 40 and 160 becomes the extreme of the design, and this 80 milligram is the intermediate level. So according to this bracketing definition, this intermediate level testing can be omitted provided these extreme levels are tested. So you need to only test 40 milligram and 160 milligram valsartan capsule for the time points according to your plan 0, 3, 6, 9, 12, 18, 24, 36, 48 according to your proposed shelf life. And once you confirm that okay, now the 40 milligram and 160 milligram really meets the specification up to 48 months, you can also propose 48 month as a shelf life for 80 milligram dose also. Now this is more interesting and quite complex also. How the bracketing concept can be used across the different across the different container closure size and even different fields. Let us understand with the help of first example. Now what is this example says? Same container closure system. So you are having the same container closure system, maybe in terms of its thickness, maybe in terms of its material like HDPE. Designing of the container closure system is one and the same. But in the example number one, the container size varies while the fill remains constant. So you are going to have the fill constant, but the size of the container is going to vary. And look at this example number one. I've taken the example of tell me certain tablets 40 milligram. So what I said as a part of this first case, the container size varies. So this is the container used, HGP container, 30 cc, 60 cc and 90 cc. What is the next statement? While the fill remains constant. So I am going to keep the fill constant. 30 counts of 40 mg tablets, the 30 counts of the 40 mg tablets, and again 30 counts of the 40 mg tablets. Have I kept the fills constant? Certainly yes. Now to understand this, you know, the very important point over here is how to understand the extreme conditions. And I will take you to the Excel sheet just to understand how this can be done. Let me bring the Excel sheet over here, and this is the example number one. I hope you can able to see the Excel sheet. And here is the example. The container size is 30, 60 and 90, and the number of tablets were same, 30, 30, 30. Let us assume for some time that the volume occupied by one tablet is 0.5 ml. What I said, the volume occupied by one tablet of telmisartan 40 mg is 0.5 ml. The volume occupied by total number of tablets will be how much? As there are 30 tablets and one tablet occupies 0.5 ml volume, the 30 tablets are going to occupy 15 ml of the volume, right? So for 30 cc container, the 15 ml will be occupied by the 50 ml will be occupied by total number of tablets. In case of for 60 ml container also, the 50 ml will be occupied by the tablets. In 90 cc container also, the 50 ml will be occupied by the tablets. Now, as this container size is 30 and the 15 ml is getting acquired by the tablets, how much is the free headspace volume available? Just by subtracting the volume occupied by the tablets from the actual container volume. So the container volume in case of 30 cc is 30 ml. 30 minus 15 gives 15 ml as the headspace volume. For 60 ml container, the headspace volume will be 45 ml. And for 90 ml container, the headspace volume will be 75 ml. Now this is the volume which is available just above the tablets. And this is the critical space because this volume can have the air, it can have the moisture, and if your product is moisture sensitive, if your product is oxygen sensitive, the more is the volume, I mean the more is the headspace, the bigger will be the impact. Now let us understand this. So the headspace ml per tablet, I have calculated what the headspace per tablet now, as there is a 15 ml of the headspace available here, right? For the 30 cc container, how much is the headspace available? The 15 ml headspace is available, which is just above the tablets. Now if I calculate that how much of the headspace per tablet is available, and I have 15 tablets in the container, so 15 tablets is a container, and the 15 ml of the headspace available inside the container. Sorry, it is not the 15 tablets, but there are 30 tablets in the container. So if there is a 15 ml of the headspace available, and if there are 30 number of tablets available, so will you be able to calculate the headspace in ml per tablet? So per tablet or each tablet will have the exposure because of the 0.5 ml headspace. I mean the oxygen or the humidity contained inside the 0.5 ml will be available for one tablet. I am talking about the 30 cc container. Let us understand the headspace per tablet for 60 cc container. As there are 30 tablets, right? The headspace available is 45 ml, and then the headspace in ml per tablet will be 1.5. That means you can imagine that the exposure for the humidity, for the oxygen will be greater in 60 cc container as compared to 30 cc container. Let us understand the scenario present into a 90 cc container. In the 90 cc container, the 75 ml of the headspace is available. And how many tablets are there? Of course, 30 tablets, right, across each container. So the 75 by 30, you will find that the 2.5 ml of the headspace is available for one tablet. Now tell me, according to your understanding, logic, which tablet or which container can have the greater exposure, and it will become exactly the 90 cc container, because there is 2.5 ml of the volume available, and then comes the 60, and then comes the least one, that is 30 cc. Now if I have to calculate which one is the extreme, now will you be able to identify the extremes now? Extreme means what? The design which will have the minor impact, and the design which will have the critical impact, and sure, the middle one is the intermediate level. So according to this calculation, you can easily understand that the 30 cc and 90 cc containers are at the extremes, and hence they needs to be tested as per your bracketing plan, and the 60 cc container can be excluded or can be omitted. Now if you look at the another calculations, I have not discussed about that, but this is something which is called as headspace to volume ratio. What is that? Headspace to volume ratio. Now this is the term I found used in the bracketing guideline. You can also calculate the headspace to volume ratio, and you will still find that the 30 cc is again a minor one, the 90 cc is again a critical one, and the 60 cc is again an intermediate level. The headspace available. The headspace available for 30 cc is how much? Look at here, it is the 15 ml. And what is the entire volume of the container? Of course 30, right? So 15 by 30 becomes 0.50. Similarly, for 60 cc container, the headspace available is how much? 45 ml. And what is the container size? It is 60 ml. So 45 by 60 gives 0.75. And again for 90 cc container, the headspace available is 75. And if you calculate the headspace to volume ratio, it becomes 0.83. Again, the 0.83 is critical, and 0.50 is the minor, and 0.75 is the intermediate. But if you look at these two different factors, headspace to volume ratio and headspace to tablet, I really get appealed by these values because they are more prominent, significant as compared to the headspace to volume ratio. But you can decide on to calculating any one of them, and you will understand the extreme condition as well as the intermediate condition. Let us go back to the presentation. Alright, so now you must have understood why the 30 cc with 30 count and 90 cc with 90 counts are considered as the extreme condition, and why the 60 cc and 60 count is considered as a intermediate condition. I'm talking about the, oh, I'm so sorry. Let me go back to example number one. Alright, so excuse me. So you must have now understood why the 30 cc and 30 count and 90 cc and 30 count as considered as a extreme condition, and why 60 cc and 30 count is omitted from the stability testing. Let us now talk about the example number two, or the second situation. We are talking about how the bracketing design can be used in case if there is a different container closure size and a different fill. In the second example, the same container closure system, but the fill varies while the container size remains constant. So your fill is going to vary. Means the number of count, number of tablets are going to get varied, whereas your container size is going to remain constant. And here is the example in front of you, HDP container. Look here, there are 90 cc container across all three different designs, whereas the count, the number of tablets is 30 in one container, 60 in another container, and 90 in another container. The fill is getting varied. 30 counts, 60 counts, and now 90 count. Now, before I discuss about extreme and intermediate, let us go back to the same Excel sheet to understand, how this can be calculated. Let me bring the Excel sheet on the board, and here is the example number 2. In this example, the size of the container is going to remain constant, but the fill is going to get varied. The 30 count, the 60 counts, and the 90 counts. I have used the same Excel sheet. The volume occupied by one tablet is considered to be 0.5 ml. Then I got that the volume occupied by total tablets is now 15 ml in case of 90 cc. Then in another case with 60 counts, it just become double the 30. And for 90 count, it becomes 45, isn't it? So, yeah, let me adjust the Excel sheet little over here. So headspace in ml. So I know that the 90 cc container has 90 ml entire volume, and the 15 ml is occupied by the tablets. So how much will be the empty headspace volume available? It's 75 ml. The 60 ml for 90 cc in 60 counts, and 45 ml of the headspace will be available for the 90 counts. I hope you understand the calculation of the headspace. Then I am going to calculate the headspace available per tablet. Now there is 75 ml of the headspace available, and how many tablets? There are 30 tablets available. So 75 by 30 gives 2.5. Means per one tablet there is a 2.5 ml of the headspace available. In the second situation where 90 cc container used and 60 number of tablets are packed, we know that the headspace available is 60 ml. So 60 by 60 is going to give me a headspace available per tablet. It is 1 ml now this time. 1 ml per tablet. And look at the third situation where we have a 45 ml headspace and 90 number of tablets available. So the headspace available per tablet becomes 0.5. Now by looking at these three figures, 2.5, 1 and 0.5, what you understand that in case of 90 cc and 30 counts, there is a high exposure of the tablets because the headspace available is much higher as compared to 60 counts, as compared to 90 counts. And if the headspace available is more per tablet, there can be more exposure because of the humidity, there can be more exposure for the oxygen, there can be a better chance of the thermal degradation. And because of that, the 2.5 headspace per tablet becomes the critical one, which is related to a 90 cc container and 30 cc tablet. Then the least one is zero point 0.5, the 90 cc container and the 90 tablets. And then the immediate intermediate becomes the 90 cc container and 60. So, and same can be seen for the headspace to volume ratio also. So the my 90 cc container, the 30 count is critical. 90 cc container and 60 count is intermediate, and 90 cc container with 90 tablets is a minor. So tell me now, which two conditions are extremes in this situation? Obviously, the 90 cc container with 30 counts and 90 counts. And which condition can be omitted, by the way? It is 90 cc container with 60 counts. I hope you understand again how these extremes can be identified. So let me go back to the presentation one more time. And here is the extreme conditions I just mentioned over here for your understanding. Let us now understand the third example. Okay, and I think, yeah, this was the second example. I'm so sorry. And let us now go back to the third example. So what third example says? Yeah, let me take the pointer over here. The third example says that the same container closure system where both container size and fill varies. Both container size and fill varies. And look at the example over here. The tell me certain tablets 40 milligram. SDP is the container. In one situation, the 30 cc container with 30 tablets, 60 cc container with 60 tablets, and 90 cc container with 90 tablets. Now, in this situation, Both the container size and fill varies. Let us now understand the extremes and the intermediate level. Let me bring the Excel sheet one more time, and here is the example number 3. Both container size and fill is changing. 30 cc container 30 tablets, 60 cc container 60 tablets, 90 cc container 90 tablets. The volume occupied by per tablet is 0.5 ml. So calculate the volume occupied by total number of tablets. It is 15 ml in case of 30 cc, it is 30 ml in case of 60 cc, and 45 ml in case of 90 cc. Will you be able to calculate the headspace now? Absolutely yes. Thus 30 minus 15 becomes the headspace available for 30 cc container. Then 60 minus 30 becomes 30 ml as a headspace available in the 60 cc container. And 90 minus 45, which equal to 45 ml, becomes the headspace available for the 90 cc container. Let us now calculate headspace available in ml per tablet. So 15 ml of the headspace available for 30 counts becomes 0.5 ml. 30 ml of the headspace available for 60 counts, again it becomes 0.5 ml per tablet. The 45 ml of the headspace is available for 90 tablets, and it again becomes 0.5 ml. So by looking at all these three different the packaging conditions, you will realize one thing, that there is no extreme, I mean, there is no minor, there is no critical, there is no intermediate. It looks like that all these three different packaging going to expose sample with the same intensity. And look at the headspace to volume ratio also, it remains 0.5 across all these three different combinations. And hence now you can think of considering the lowest volume container and the highest volume container, and the intermediate can be considered as as the middle container, like 60 ml with the 60 number of counts. So out of three, anyone can be omitted, by the way, but decision on omitting 60 cc and 60 count is based on its intermediate pack size. I hope you understand how it has been, how we arrived at the extremes and the intermediates. Let us go back to the presentation now, and here is the presentation. Let us now talk about the fourth condition, same container closure system, where both container size and fill varies. Again, both container size and fill varies, but look critically in the last example now. Example number 4, tell me certain tablets, HDP container 30 cc 10 tablets, 60 cc 40 tablets, and 90 cc 50 tablets. Let us now evaluate the extremes and the intermediates. Let us understand. Let us take the example number 4, and here it is on the screen. 30 counts, sorry, the 30 cc, the 60 cc, and the 90 cc, 10 counts, 40 counts, 50 counts. The volume occupied by one tablet is again 0.5 ml. The volume occupied by total tablets in case of 10 counts is 5. In case of 40 count, it is 20 ml. In case of it is 50 count, it is 25 ml. So how much is the headspace available across these different containers? For 30 ml, the 25 ml is the headspace. For 60 ml container, the 40 ml will be the headspace. And for 90 ml container, the 65 ml will be the headspace. Now let us calculate the headspace per tablet, the ml available of the headspace per tablet. And you will find that in case of 30 cc count with 10, a 30 cc container with 10 count, it is 2.5 ml. In case of 60 cc container and 40 count, it is 1 ml. And in case of 90 cc container plus 50 ml counts, a 50 number of counts, it is 1.3. Now according to your logic, we should be a critical, and you will say, okay, 2.5 is going to expose much higher, and hence the 30 cc and 10 count become the critical. Absolutely right. Now let us understand the minor one, whether this 1 ml per tablet or 1.3 ml per tablet is going to be minor. Absolutely 1 ml per tablet, right? It is a minor one. It is going to have the least impact as compared to the 1.3 ml per tablet, and hence our 60 cc and 40 number of tablet becomes minor in this case. And what becomes intermediate? 90 cc and the 50 number of tablets. So it is not always the extreme of the size of the container always becomes the extreme of the conditions. You need to understand and decide based on to what is the impacting factor. And in case if the impacting factor is the headspace, if your product is prone to get degrade into the humidity, oxygen and the temperature, then according to that, the headspace available is certainly going to impact and certainly going to decide on to the extremes in the bracketing design space. Let us go back to the presentation. So the extremes in the last example is 30 cc 10 counts and 60 cc 40 counts, and intermediate becomes now 90 cc counts with the 90 cc with 50s counts. So this is the example we talked about how one can use bracketing designing for the oral solid dosage form across different strength, across different container closure size, as well as different fill size too. Let us now understand how the same concept can be used to for the oral solutions, and it can also be used for the oral solutions as like tablets, as like oral solid dosage form. But here in the guideline for oral solid dosage form there is a one more um, possibility given. As we said that for oral solid dosage form it must be a dose proportionate formulation. The content of excipient should be one and the same. The ratio of API versus excipient should be similar across all the strength. Now here is a small exclusion from the number of excipients or the excipients present into a sample. The colorants or the flavoring agents can be excluded. And here is the example I just tried to give one over here that for valsartan oral solution 40 mg, the colorant is different. The coloring agent is iron oxide yellow. In case of valsartan oral solution 80 milligram, the iron oxide red is the coloring agent. Whereas for 160 milligram oral solution, it is the iron oxide black. But it's very important to understand that we need to justify how the different in coloring agent or flavoring agent is not going to impact onto my drug stability. And for that reason you should have some development stability data which is going to say that okay, now different colorant is not really going to make any different as far as the stability of the product is concerned. And then according to the bracketing standards, these are the three different strengths: 40 mg, 80 milligram, and 160 milligram oral solutions. You very well know that now, in case if it is the same container closure system, 15 ml, then the 40 and 160 is going to become part of your stability study, and 80 milligram can be excluded from the testing plan. Now, in case of multiple container size and multiple container fill, how you are going to decide on to the bracketing. Now here is the example over here now. There are three different dosage strength: 40, 80, 160 milligram. It's oral solution again. But now it is not only one container size, but there are three different container sizes: the 15 ml, the 100 ml, and the 500 ml. So what is the logic? In case of bracketing, you can exclude the intermediate label claim or intermediate packaging or the container size. So 80 milligram is excluded, and again the 100 ml is excluded. Let me show you with the example of how this looks like. Now this is the plan for the valsartan oral solution 40 milligram, 15 ml, 100 and 500 ml as the fill volume. So the 15 ml and 500 ml has to be tested, and 100 ml can be excluded. For 100 ml, And for 80 milligram, as it is intermediate label claim, you need not to test the product across any of the fills volume, neither at 15, neither at 100, and neither at 500. All can be excluded. And when it comes to 160 mg of the oral solution, and again the intermediate is what, 100 ml. So 160 mg 15 ml, and 160 mg 500 ml has to be tested. Let us now understand the limitations of the bracketing systems. So bracketing study needs to be continued with extremes, even if extremes gets dropped out of the business plan. Right? You initiated the stability plan with 5 different strengths, and you understand the extremes now. Even though the fourth and fifth label claim has been dropped out of your business plan, still you need to continue with the same extreme testing conditions. The shelf life with respect to extremes will be granted to the intermediates, even if intermediates are more stable naturally. And among these extremes, the least shelf life will be considered for all the strength, all the container closure volumes. Bracketing may not be accepted for complex formulations such as MDIs. Bracketing design is not appropriate if tested samples are not extremes. So identifying extreme is very, very crucial if you are applying bracketing concept. And last but not the least, bracketing generally should not be applied in cases different excipients are used among strains. It's required to have the similar kind of excipients across the different strains. So this is the presentation I thought of giving today to make your concept super clear onto the bracketing concept. Thank you so much.